Now, see here, I'm going to explain crystal field theory. Before crystal field theory, valence bond theory was there. Okay, what was valence bond theory? How the electron was distributed in the valence? What is that ground state, excited state? What is that color? That all we studied. No, for each compound we used to study. But valence bond theory had some exceptions. What are the exceptions? Is it used to have more of assumptions, so that was the more exception. Nani sound taku say. Next, it does not give magnetic data. It will say that if the unpaired electrons are there, it is paramagnetic. If all it is paired, it is diagramagnetic. It will say, but what is that value? Quantitative interpretation for the magnetic data, it was not given. And it said that it is colored. Unpaired is there means it is colored. Paired if there isn't, it is not colored. It said it is colored, but which color and all, VBT did not say. And he did not say about the thermodynamic and kinetic stabilities and all, it was not explained. Okay. And also if the coordination number is 4, whether it is tetrahedral or square planar, exact prediction was not done. It can have both tetrahedral and square planar. Both was not explained properly by VBT. And it does not distinguish weak field and strong field. Now we'll say all the carbon and oxygen and all, they are strong. Nitrogen, they are strong. Chlorine, water and all, they are weak, we'll say. But it was not explained by crystal field theory. What is that? VBT. Now what is crystal field theory is, now the d orbitals will have all degenerate orbitals. Degenerate means they will have all same energy level. Okay, dx square minus y square, dx z square, dxy d, they will all have same energy. Okay, when they have symmetrical negative charge around that, their energy raises. Okay, just a symmetrical, when the ligands are coming close, it will get excited. Then also it will maintain its new what is that, degeneracy. Degeneracy means the orbitals will have the same energy level. This is, we are talking in case of octahedral. There is a difference. Okay, when the ligands come close for making bond, what happens is, this 5d orbitals, they split into two. In octahedral, down will be T2G, up will be EG. You remember T2G is always dxy, dxz, then dyz. These are T2G. Okay, EG is dx square minus y square and dz square. Why this happens? Always remember T2G is these three orbitals, EG is these two orbitals. Why this happens is because the ligands will come along the axis. Okay, dx square y square is still along the axis. Okay, it is along the axis. So only x square y square, even z square, see, this is along the axis. dxy, dxz, yz, this is between the axis. The ligands are not coming between the axis. Here the ligands are coming along the axis. So these orbitals will have higher energy. Okay, then what happens, these orbitals energy is decreased by 2 by 5 delta naught, and this is increased by 3 by 5. Okay, or else you can remember 2 by 5 is zero point 0.4, here 0.6. Zero point 0.4 delta naught, it is decreased. Okay, this is about octahedral. Same thing happens here also in the tetrahedral case, but it is ulta. Why? Because here the ligands will come in between the axis. If they come in between the axis, the orbitals which are in between x y y z zx, they become higher. Always remember T2G will not use here. We will use G only for octahedral because they will have symmetry, and we'll use for square planar also. Square planar is not in your syllabus, don't worry. We'll use for octahedral T2G. Here we'll use only T2 and E. For E, always it is dx square minus y square and tz square. Here, why it happens? No, the ligands will come along in between the axis. So T2 will go up, E will come down. Rest all it is same. Okay, this was explained by CFT. This is the exam. What is that? Two differences, and based on that, how the splitting occurs. This the difference between these two. Okay, the energy level between, see, this is the energy level we are plotting. The energy level between these two is known as delta naught. Here delta T, and what is the relation is delta T is less. The least is delta t. Delta t is equal to 4 by 9 times of delta naught, and this energy is known as crystal field splitting energy, and this center is known as Barry center, and this is the standard zero, considered as zero. Okay, and based upon the behavior of the ligands, this is arranged like this. See, carbon and nitrogen, they are considered more strong field ligands. Now what happens, this is known as spectrochemical series, means the strength of the ligands are arranged in the increasing order, field strength. So that is known as spectrochemical series. Now what happens if there are one electron means, see, uh, 1 2 3 4 5, here one electron will be there. They think this is octahedral. Octahedral means what happens, the splitting takes place. How it takes place, here 2 will come, here 3 will come, here 2 will come. This is T2G, this is EG alva. This one electron will go here, uh, when the splitting occurs also. And one more, if two electrons are there, it will go here. If three electrons, go here. But fourth electron, from the fourth electron, difference takes place. Now that case you have to consider these two. What are these two? If delta naught, if this is only more, if this is if this is only more, pairing occurs. If this delta naught is more, if the energy, the electron cannot jump up, pairing energy is less, delta naught is more, that time we call it as ligand is strong. When the ligand comes, this becomes more, means it is strong ligand. Okay, now see here, if the pairing energy is only more, that time what happens, no pairing occurs. This one more, one two, fourth electron will go here. Understood? No, 1 2 3 electron, no problem. Fourth electron, question mark, where you have to, it has to go, either whether it will go to T2G or EG. If the this what is that, the CFSE is more, delta naught is more, means pairing occurs. Here only pairing occurs, then it is called a strong ligand. If this is less, pairing energy is only more, then it will go to here. See here, fourth electron enters 1 to EG when pairing energy is more. Pairing energy is more means does pairing does not occur. Pairing energy is less means pairing occurs. Okay. Now, if the pairing does not occurs, then it is called as weak field ligands and form high spin. You remember, pairing energy more, electron will go to EG. It is a weak field and it is a high spin. Vice versa is others. Don't remember both. Remember only one thing. So this all happens. They will ask electronic configuration. Where does the electron? For example, here D5. D5 is there. This is more. Splitting is more. Means CFSE is more. What happens? T means no pairing occurs. T2G, EG. What will be the configuration? Here 3, here 2. No pairing occurs because pairing energy is more. If pairing energy is less, okay, this is more. Pairing energy is more means this. Pairing energy less means what happens? T2G5, EG 0. This happens. Pairing occurs. If pairing energy is less, it is weak field. Pairing energy is less means strong. It is strong field. Sorry. Pairing energy is less means it is strong field. Pairing should occur ma. Pairing is occurring means strong field. Pairing is not occurring means weak field. Okay, hope you understood. If any doubts, you message me. I'll make a video. Okay, this is spectrochemical series. You have to remember. In that video, sir have taught some this no mnemonic. According to that, you can remember.